Why is the fractal nature of this geometry important?
Well, again, I think it's because what I've been kind of trying to reiterate here is that the fractal nature of it shows that there's this relationship. It's not just arbitrary. Like typically, if you build something just randomly, you build something and then you subdivide a room out of it, and there's no particular relationship between the room and the whole building. Or in the painting, you just choose, well, I'll put this here and I'll put that there. Maybe if you're really intuitive and really good, like some artists who I probably didn't know the system, nonetheless, their intuitive sense about it, they had that sense of proportion. So they knew that if they arrayed their composition in a certain way, that inherent within it, underlying the outer forms, were these geometric relationships between the part and the whole. And again, the idea is if the geometry is similar, if there's a self-similarity between the part and the whole, then there's a resonance between that. And now the composition becomes dynamic rather than static. And see, it's the static situation is basically like the non-living. And when you go from the static to the dynamic geometry, that's going from the non-living to the living. See, so the idea was to try to create a composition, whether it was a work of architecture, whether it was a woven rug, whether it was a stained glass window, whether it was a painting. The idea was that there was this dynamic relationship, this geometric proportion of harmony between the part and the whole. See?
Makes sense.
That's kind of what we have going on right there. And so there's the full kind of flower of life, and you can do all kinds of things with it. You know, if you go online and put this in, you'll see people have done all kinds of wonderful things with colors and shadings and all of that. So, and then of course it gives one of the basic geometric proportions of the you know, of the ancient architects.